Good morning. In today's lecture we'll see some further reactions of alcohols, and we'll continue with the reaction that we ended with last time. That was basically the conversion of alcohols into alkyl halides. We've seen one way so far which involves treatment of alcohol with concentrated HX, that can be HBr, HCl, or HI, and upon formation of cation, halogen displaces the water and forms alkyl halide. However, there are several issues with these routes, and they're mainly concerned about use of strong acidic conditions, as well as potential formation of cations, which then leads to rearrangements and eliminations. And for a long time, people tried to find a more efficient way to convert alcohols into alkyl halides, and the way that was discovered is the use of phosphorus halides, such as PCl3 or PBr3, which then convert themselves into phosphonic acid, as well as providing us with alkyl halides, like either bromides or chlorides. A very similar reaction can be performed with Pi3, except that Pi3 is not very stable, so it's produced in situ from phosphorus and iodine in elemental form. And this will give us alkyl iodides, and again, phosphonic acid. This works quite well with primary and secondary alcohols. It doesn't work too well with tertiary alcohols, and the mechanism explains why. So the reaction starts with a nucleophilic attack onto phosphorus, nucleophilic attack by oxygen, which leads to displacement of Br- and formation of this activated alcohol, which is then back attacked by bromine, since this phosphorus hydroxybromide is a very good leaving group, and that gives us RBr and phosphorus OH Br2. And this explains why this doesn't work too well for tertiary alcohols, because this is simply an SN2 reaction. It's synchronous and occurs more readily with primary and secondary alcohol. Now, since this method is good for making alkyl iodides and alkyl bromides, it works quite well with alkyl chlorides as well, but we'll see in the next topic a more efficient way, and it's the reaction of alcohol with thionyl chloride. However, the benefits of this method in general sense are that no cation is formed, and hence there is no possibility for rearrangement and formation of undesired alcoholic products.